Okay, welcome everyone. Hope my voice is okay. All right, can you all hear me? Okay, so we can start the lecture. All right, good evening and welcome. So today is our sixth lecture, and we'll be talking about object-oriented programming today. Okay, so in our last class, we've spoken about some, I believe, functions. So in today's lecture, we'll talk about object-oriented concepts in Python. And basically what we'll cover is the concept of a class, object. We'll also talk about some principles of object-oriented programming with Python. We'll look at encapsulation, inheritance, and then we'll also talk about how to override um, some functions. Okay, so I believe some of you have seen something like this before. It's called potato printing. Potato printing. Basically, what you do is you cut a potato in half and then you draw a shape on a part of the potato, then you put it inside some ink and then you press it on a piece of paper. So when you do that, you have different shapes of that potato on the paper. So I'm using this analogy to describe what a class is. You can think of the potato as your class, and then the shapes as and color of the potato as your properties. And then when you print it on the paper, you can think of those as objects. Those are instances of the class. So when we talk about class, we're talking about a blueprint or a model or a prototype, often defined by the user, which is you. Okay, so you can make classes in Python. When you define the class, you can now create objects based on the class to do whatever you need to do. So your class usually will have attributes, which are properties that define the class or describe the class. Then you also have methods, so what your class can do. Okay, so usually you access them using the dot notation. You will see this in an example. How do you write a class in Python? You start with the structure. You have a class, it's a keyword reserved in Python, and then your class name. This class name, you decide what you want for it. Okay, so after that, you have the colon, and then you indent. So everything inside this class is indented, either with two spaces or with a tab, depending on your preference. In your class, you can have what we call documentation string. It's usually a one-line string that describes the function of your class or what your class does. Okay, and then the other things in your class, you put it after that. So here you see we have class suite. Your class suite can be the other class members, it can be your data attributes, it can be functions, all those things that are part of your class, all right? And then when you want to get the documentation string for this particular class you've defined, you can use this notation. So the name of the class dot double underscore doc and then double underscore. So we'll talk about briefly what this is later, okay? But you can think of this double underscore as special. Basically, anytime you see something between double underscore, they are special functions in Python, and they are reserved in these words are reserved. So you have to use them as you see them in the documentation. This particular function doc with preceding underscore and then trailing underscore helps you to get the documentation string of that class. Okay. All right. So an example of a class. You see here, we have a class called cat. So class, as I said before, is a keyword. This time the name of the class is called cat. We are defining what we want as the class name, cat. And then we have a function or a method for the cat class. So inside this method, you see the name of the method, speak, and then it just prints the way the cat speak, in this case, which is meow. All right. So you're familiar with methods because we've talked about in the last class. You see here that we've passed self as a parameter to this method speak. And when we talk about this keyword self, we usually pass them in the functions in a class. And self represents the particular object that will be created from this class. So in some other languages, they use the keyword this. In Python, we use self. Okay. So, all right. So now that we've talked about what a class is, let's talk about objects. Objects are instances of a class. So one instance of a class is called object, or you can think of them as examples of a class. Your objects can have attributes and then they can have behavior. So attributes here refer to properties and behavior refers to functions or methods. So when you're creating an object, you create it like this. You give a variable and then you assign the name of the class that you want to instantiate. So in this case, we're using the cat class and then you put parentheses. Okay. So that means that cat1 is an example of a cat. This is an object of a cat. And you can actually use the type function to print cat1 to see how that looks like in Python. Okay. So we have our class again, cat. And then here we see that we've instantiated an object called cat, lowercase c. All right. So when you've instantiated the object, you can use the method that was defined in the class. So when you say cat.speak, it will run, Python will run this function. All right. And you should get this type of output. And then if you try to check the type of this object cat, you will get this type of output. And this describes to you that cat is of the type class of cat. Okay. And then this is the file where that cat is being defined. Okay. All right. So We have another method here in the cat. We call it the init method. And you see here, this init method has double underscore preceding it and then double underscore trailing it. So the init, we use it as a constructor for the class. You can see here that we are supplying self to this init method, and we're also supplying another variable called name. Okay, and then name, we are creating a property in this class called name, and then we say self.name. So this self.name will be the name of the particular object that is created from this class. Okay, so self.name here is the name of the particular name of the object created from this class. And we are assigning the name we get from this init function to it. All right. So once you've defined this init function, you can now change the way you create the class, objects from the class, sorry. So you see here we have cat and cat2. These are two objects of the class cat. And for this cat here, we pass Tom as a name. And this cat here, we pass Butch. So anytime you say cat1.name, you are getting the name of cat1, which is Tom. And when you say cat2.name, you are going to get Butch, which is the name of the different cats. So this is possible because here we say self.name, and then we are assigning the name we pass to it. So you can think of this as your constructor. Okay, so when you are initializing a new class, whatever you pass here can be passed to this init function, and then you can now set up your class. All right, so this is just an example here. I'm just passing name. You can decide to pass more than one variable if you wish. All right. Okay, so here we see that we have another method called getName. All right, and getName is going to return the name that we've defined here. Okay, so this getName method returns the name that was defined and set here. All right, so that when we have these two cats again, if we now try to get the name of one of them, you should get the name that you assigned before. And then the same thing when you get the name of cat2, you should get Butch, which was the name that was assigned here before. All right, so sometimes you may want to use what we call getter and setter methods. So this is a getter method where we define a method to return a property of the class. Initially, we had said cat.name, so this is an alternative for you. Sometimes you may prefer that you do cat.getName, not getting the name directly. You may want a method that you use so that you don't get the name directly. So it depends on your design. Okay, so here we see that we have a setter method, and we can use this to update the name. So you see inside this setter method, we are passing name again, and then we are overriding the name. So self.name gets assigned the new name that we pass. All right, so we have the same program that we had before. So Tom and Butch, and you can get their names, and then you can also rename the class. So if we say cat2.setName, this renames cat2, so that when you set it to black, anytime you do cat2.getName, you should get black and not Butch. So this should be black. Okay, I'll make a correction to that. You can try these codes in your spare time, and you'll see that this name actually gets updated. That's the name of the object cat2. Okay, another example of the class, we have here a new class called student. You see here I've put a docstring to describe what the cat does. sorry, what the class does. And here, this is just the base class for all students. I have a new variable called count, and I assign it to 0. Now, inside my init function, you see that I have two parameters that are going to be passed as arguments. One is name, which we assign to this name variable. The other is matric number, which will be assigned to this matric number variable. Then you also notice that I am counting the number of students. I'm increasing it, okay? So that anytime we instantiate a new student, anytime we create a new student, what happens here is that the number of students increases. So that anytime we try to get the count of the student, like you see in this method, display count, this will give us the total number of students that we have created in the program. All right. So I'm using this count variable to track the number of instances of the students that are created when we call this initialize function. Okay. So we also have another method here, and this one just displays the student. So what it will just do is print the student's name and their matric number. So now this S is an example of an object. We are instantiating a student called Edbello, and then we are given this matric number UJ 2018 NS0012. So if I display the count of the student, at this point the count is 1 because we've only created one instance of students. All right. If I display the student's details, so s.display student, we'll get the student name and then the student's matric number. Now I've created another object called S1. This time is Aisha Ali with matric number UJ 2018 NS0178. Okay. So after creating this, you know that we have two students now. So that when I do s1.display count, we should see that the total number of students is 2. So this is a typo. I'll correct that in the before I distribute the notes. This should be 2. And then you can also display the details of of student 1, okay, which is her name and then her matric number. All right, so you can try these examples to see how they work. Your classes can also interact with each other. So in this example, you see that we have a class called student, and then we have a class called course. So this class is responsible for creating student objects. This class is responsible for creating the course objects. You also see here that inside this course class, we have students. Okay, so we have the name of the course, and then we are expecting a list of students. All right, so we can pass a list of students to this class. Then this course class also has a method to add students. Okay, so we add students to the course, and then we can also get the average grade for all the students that are taking this course using this method. Basically, what happens here is when we call this method, we're going to loop through all the students that we've added. Okay, so this add student, basically what we do is as we add student to the course, we're going to keep adding members to this list. So each student join this list. That's what the append here does. Okay, and then when we're trying to now check the average, we'll first get the total grade of all the students, which this loop is responsible for. It will loop through all the students in this list and then add their grades together. Okay, so this should be total grade, not total, sorry, total underscore grade. So this is total underscore grade plus equal student.grade. So now when we now try to do student.grade divide by the length of this list, which is given to us by this len function, we should now get the average of the students. So I'll correct this in the notes. This is total underscore grade. All right. So you try out the class. We can create 3 students as you see here. We have 3 student objects, Napang, Ali, and Aisha. And then we've created a course called math. We can add the 3 students to the math course, and then we can now get the average grade of all the students in the math course. So because these are their grades, 60, 30, and 75, the average we should get is 55. Okay. All right. So now we've talked about classes and we've talked about objects in Python. Another thing you can do in Python is encapsulation. So I'm sure you're all familiar with a capsule. All right. This capsule usually is a gelatin case that holds a powder inside. Once you break the case, then you can now see the powder. All right. So we use this to describe exactly what encapsulation is. So with encapsulation, what you are doing is you are wrapping data inside, you are wrapping data with a mechanism so that it's not easily accessible to other parts of the program. Okay, that's what we mean by encapsulation. So basically what you're doing is you're hiding some part of the data. Okay, so we do this to limit access data. It can also be method, not just data, or any other component of the class that you would like to maybe protect from the from other parts of the program. Okay, so we use encapsulation, and the way you do it in Python is that you will declare a private variable or a private method. So to declare private variable in Python, we don't actually have the keyword private like programs like C++ and C# and Java. All right, so the naming convention usually is that for your private variable, you use 2 underscores before it. All right, so secret count here has 2 underscores before it, so we know it's a private variable. That means that we can use the class. So you see here where we've used it to increment the count of the class. Okay, so that when we call this method, we increment secret count, and we can also print the secret count. All right, so if you create an object called fruit1, okay, based on the fruit class, and then you count, right? At this point, your count is 1. And if you count it again, you call the count method again, at this point your count is 2. But you will notice something. Anytime you try to print fruit1 dot underscore underscore secret count, which is a private variable, you will get an error. Okay, so I've commented it out, but you can uncomment it as you try the code and see the type of error you get. Python will warn you that secret count is not accessible. Okay, so you know that you are trying to access a private variable in the wrong place. Access it, then this is how you will write it. Okay, so you can try this and see what you get. Okay, so the other thing to note is that besides private members or private variables, you also have what we call protected members or protected variables. So in a language like C#, you see they use the keyword protected. Okay, and I think C++ as well. But in Python, we don't have private, we don't have protected, we don't have public. So the way you know what a variable is or a method is based on the way it's named. All right, so if you have double underscore, that means you're working with a private member. If you have just 1 underscore, as in the case of seed, that means you're working with a protected member. Then the protected member, they are similar to the private members, but The only difference is that they are also accessible by your subclass. So we'll talk about subclasses very soon when we talk about inheritance. But what you need to remember is your private members are only accessible to the class is being defined in, and then your protected members are accessible in the class is being defined in and any other subclass that inherits from that class. All right, so we've talked about encapsulation. Let's move on and talk about inheritance. So inheritance in programming is the same thing as, is similar to the concept of inheriting in real life. Basically, what happens here is that you can have a class with methods and properties that is child or children. So this is the class that you are inheriting from. So we call it parent or base class. Then the class that does the inheriting, we call it child or derived class. Okay, so it's being derived from another class. That's why they call it derived class. Sometimes you parent class, and then there can be one or more child or children classes. All right, so this picture shows you inheritance. Basically, what happens here is you have your parent class. Sometimes it's also called the super class. Okay, and then you can have one or more subclasses that will inherit methods, properties, or other components of the superclass. Okay, so that's what this diagram illustrates. And to show you an example, we have a class called animal. Okay, so animal has two methods. You see they have the underscore underscore and then the name of the method underscore underscore. So like I said before, these methods are reserved in Python. So to know what they are, you check the Python documentation. So the init method, basically this is where you initialize your class. All the things you need to do to set up your class, you do it here. It's similar to constructors in C++ and C#. All right. Then we have the string class. This string, basically what you use it for is just to get the string representation of your class. All right. So you can look more on that in the documentation. Now we have a class here called cat, and you see in brackets we put animal. This is to show that the cat class is going to inherit all the properties and methods inside the animal class. The same thing here. Oops, let me go back a bit. The same thing here with dog. You see that dog class also has animal in brackets. That is to show you a method for the dog. Okay, but basically what happens is that these two methods are also available to cat and dog because of inheritance. Okay, all right. So if you try this, we are declaring an animal instance called A. You can now use A to get the string representation of that, which will give you this. Okay, then we have another object, this time a cat, and you notice that we are passing name and then we are passing the age. Okay, if we go back, you notice that inside the cat class, there's no place where we instantiated the object, but it's done inside inherited this init function as well. That is why in this example you can do something like this. Okay, so you can pass name and age to the cat, and then if you do cat.speak, you will get that string underscore underscore and then the parentheses to get the string representation. Okay, you will get something similar to this for the cat. You can do the same for the dog as well. So I would like you to try that when you go through the codes. Then another example of inheritance, this time we have the student as our base class. and then we have PG students as our subclass. So you notice that inside PG students, we pass student in the, and then we didn't do anything again inside the PG student class. So we just put pass. So if you remember what pass does, we just continue the program. All right. So this is one way you can use. Doesn't have anything inside except the things that it inherits from the student. So that you can also create a student object, and then you can initialize it. Okay. So once you initialize it, you can also access the method in the student class. So because of inheritance, we can use them also for the PG student. So that's how inheritance works. Anything that's in the parent is accessible to you as the child, except in the case of encapsulation, where the variable or method is private, preceded by the double underscore that we spoke of. So the other concept I would like to cover in this class is called overriding. Okay, so basically what happens with overriding is that you can override attributes and methods that were previously defined or declared in the parent. You can override them in the child class. So we have an example here. We have the student class. Student class has our init method. We have also display count, and then we have display student. So I want you to notice how the student is being displayed here. The student is being displayed by their name and then matric number. All right. Then inside our PG student class, this time we have another definition for display student. So you see that display student is similar to display student here. It's the same name. All right. The same name, the same signature, in the sense that they both have self as their parameter. So everything is the same except the way they work. So in the body here, you see that we're printing just the PG student's name, right? Here we see that we printed name and then the name of the student, then matric number, then the matric number of the student. Here you see that we have the name of the student and we're just printing PG student and then name of the student. So when you run these codes and you try declaring an instance called stud, okay, which is our student object. So if you do the student object dot display student, you should get this one in the child class and not this one that is in the parent. All right. So sometimes you see that overriding is very useful for what you would like to do. Okay. So basically, these are the things that we'll be covering today. This will get you started with object-oriented programming, which you will need for one of your assignments, which I'll be giving you subsequently. Okay. So with this, I think we've come to the end of the class. Do we